Hi, this is Ms. Sherbin. I am once again also on the Amtrak station train on the way to Boston. Making a lot of videos on this train. It's been very productive. But this lesson is going to go over um, lesson 6, analyze and display data, and it's a question and answers on page 14 through 17. So I didn't make a guided instruction video for this lesson. There wasn't enough time. But I did want to go over this particular question in this graph. I thought it was a really good graph to go over, so let's look at it for a second. When we look at a graph, we should always look at what it says first. So the growth rate of two plants, all right, and that automatically, for my brain, I automatically go over here, look at the plants. We have plant A, which is a square, and plant B, which is a circle. Important to note. But then we always look at the axes, right? We have height and age. And if you remember, I always told you to label something. That cause and effect are IV and DV, right? So this is the cause and this is the effect. So the different ages of the plants has an effect on it. Well, let's look at our question. The question asks, how tall will plant A be at 9 days old? Well, if I didn't do a good job of looking at my key over here, I may have thought about plant B. And plant B is those circles. So we got 1, 2, 3, right? And I can actually make a really nice kind of line, a little bit nicer if there was a ruler instead of my finger. But I can see, right, plant at 90 days old would have been about 2.2. So if you got about that, 2.2 centimeters, no negative numbers, right? If you got that answer, that's probably why. But if we look at the boxes, right, you could almost make a line. There's no line, but we wanted to find at 90 years old, right? I followed the way. There is no dot for that. So that's why it's really important that we understand that relationship. So if this was a straighter line, right, I'd still be able to predict because we can see the trend. Trend, that's the E, T-R-E-N-D, the trend. Remember, increase, decrease, constant, all right? And this is increasing. And we can predict that 9 days, it'd be about 4.5, about 5. So if I was to make a straighter line, right, let me try again. I still end up at 4. But I could say anything around from 5 centimeters, so I can say anything from about, about 4.5 centimeters with the line I drew, anywhere to about 5.0 centimeters I would accept. There we go. Okay. So now let's go on to our other questions. Alright, for question 1, why is data organized into graphs, tables, diagrams, and other models? So why do we put the time into doing that? Well, if you ever try to look at raw data with just all numbers all around, it's pretty rough. So organized data helps us show trends, remember, like increase, decrease, and constant, or patterns in relation between variables. And remember, we have independent, dependent, and constant variables, or just like factors, how things interact. So why is it important to choose appropriate graphic to organize data? Well, if we were to do the type of growth for a plant on a pie chart, it would be nonsensical. It wouldn't make sense. If we were to do, other things like the amount of pie given to each person with a line graph, wouldn't make sense either. So, but data that isn't properly displayed will not show a relationship or trend. It won't be able to understand what the relationship is. 100 students were surveyed about who they would vote for. What is the best way to display the results? Explain your answer. A pie graph would show the best relationship, would show the relation more accurately because it's based off 100%. So pie charts are used for percentages. When there's a whole, you can show how much each is taken out of. For what are some sources of error in an experiment? What can be done to improve the quality of data? So there's so many sources of error. An experiment sources of error could include mistakes made out carrying the procedure. Like you could have put extra water in, you could have dropped something a little bit. You could have forgotten about it one day. It could be about estimates made when recording data. It could be you measured it incorrectly. You could have, even just have done your math incorrectly. So when you do it many times over again, it reduces the amount of error that happened, or it reduces the chance that that mistake will happen twice. This is why we always do experiments over and over again when we are in a scientific community. So doing the same experiment more times or doing more trials will increase the accuracy and the quality of data. All right, number 5. What are some things you must be able to communicate at the end of an investigation? So beyond conclusion and, did it support or not support your hypothesis, you can describe procedures and tools, how it went about, so that way we can replicate it, identify a source of possible error, so think about why there might have been some mistakes made, and then you should always make some suggestions for improvement, like how you can make the experiment better. Alright, so here's our next set. Objections 6 through 9. For each question, write your answers on the spaces provided. Base your answers on 6 through 9 at the table below. When I look at this table, at first I was like, oh my god, I was a little overwhelmed. There's a lot of information here. So the title is, right here, the average monthly weather for Bryce Canyon National Park, Utah. Alright, never been there, don't need to know about it to be able to read this graph. So the month, okay, so go January through December. Average high, and what they're talking about is with degrees Fahrenheit, they're talking about temperature. I know that because of the Fahrenheit. And what I can see is that there's no increase or decrease pattern, probably because here's the cold month, here's a cold month, and that's probably why the temperature, you don't see it going increase or decrease. But we do see it increasing up until July, and then it starts decreasing down here. Average low temperature. Alright, you see it again increasing and then decreasing about here. And average snowfall in inches. So we do see that there was a decrease, then there was like an increase, and that's because like the seasons, we don't start the first of the year based on the weather. It just happens to be based off of what we base it off. So I couldn't do my increase, decrease, or constant table reading here, but it was helpful to go through it and see if there was a pattern. Now it's not so scary. It's just 3 different sets of information per month. Alright, so what information can be gathered from this table? Oh, I can answer that now because I read the table. So we can find average high and low monthly temperature and the average snowfall from Bryce National Park. And I specifically wrote Bryce Canyon National Park because that's the only place where this information is about. Number 7, if you were to organize the data of high and low temperatures on the line graph, what would the label the axes? So I want to average the high and low. What they have in common is they have temperature in common. And I'd also label it months. So I put the month on the x-axis, which is also my IV, right? Time causes the changes, and temperature on the y-axis, which is also my DV. Oops. Oh well. 8. If you were planning a trip to Bryce Canyon National Park and enjoyed warm weather, explain what months would you choose? Well, if I enjoyed warm weather, I would not pick the ones that are really cold. I'd probably pick the middle months because they all have temperatures greater than 70 degrees Celsius. So I'd pick June, July, August, or September. Explain another way you could organize the average snowfall data. Ooh, well, if I think about this, right, this could be shown in a really nice bar graph. A line graph would show, like, go up and then down, but I think a bar graph would show best, so, because it shows quantities. This data could also be organized using a bar graph. Bar graphs are a good way to show quantities. And the secret word is canyon. The secret word, again, is canyon. Alright. Number 10. Look at the circle graph below. Alright, so what makes up ocean salts? We see sodium 35%, chlorine, ooh, a lot of chlorine. Didn't know that. 5.52, magnesium, sulfur, calcium, potassium, other. Oh, these sound like they're stuff in the periodic table. What is a limitation of the circle graph? Huh. Alright, a limitation. Well, it equals 100%. Is that a limitation? No, there's not a limitation. The limitation means something that like hinders it from being better. It doesn't show what salts make up the ocean. Doesn't show what salts make up the ocean. It says what makes up ocean salts. Pretty sure it does. It doesn't show the actual volume of each sea salt in the ocean. No, I have no idea. I have no idea if they're taking a lot of it, or is this just a small sample, or like how much salt is actually in the ocean. I don't know that. It doesn't show the ratio of each salt in the ocean. It does show, like I can tell that like there are to like 1 potassium, there's about like to 29 like sodium, or like around 30. I can definitely see the ratio. So it doesn't show the actual volume. All right. Look at the line, number 11, look at the line graph below. All right, how much water vapor can atmosphere hold? Grams, which is the cause, right, or the dV, the temperature. So the temperature is the IV, so the temperature affects how many grams of water vapor the atmosphere can hold. All right, predict the number of grams of water in the atmosphere hold at 50 degrees Celsius. Ooh, I like this problem. You'll see a lot of these on quizzes coming up, and just in general, it's a good skill to have. So I don't actually see 50 degrees Celsius. So what I can do is I can kind of predict by continuing the trend. The trend is as increasing, and it's kind of around the same slope. So this right here would be about, 50 degrees Celsius. That's a 50 degrees Celsius, right? This line right here. So I follow it up. I see it's about 50 grams. It's around 50 grams. So 60 grams around here. In order to do that, my line like would have to like go like that. Would that doesn't look right, right? So it can't be 60 grams. 52 where I said might be good. 35 grams. And from here it would have to go like down. Why would it start doing that? Definitely not 25 grams. It would even have to take a sharper turn down. That won't work. So it is definitely 52 grams. 12. What conclusion can be made from data in this graph? Okay, now I'm going to look at this graph. I can see the average monthly temperature, and it's talking about Rochester, New York, and San Diego. It's the IV in this is months, and the dV is temperature. Therefore, the cause, the change in months, change the temperature. I have January, April, July, October. Alright, so before I even look at the possibilities of questions, if I have the time, I'm going to make my own conclusion. That way, I don't get tricked. They're going to have like a trick answer in there. And if I make my own conclusion first, then I'm not going to get tricked. So, let's look at it. So, Rochester, I'm looking at here, it seems to always be colder. Oh, in July, it's warmer than San Diego. Here is colder. Okay, so usually it's colder in San Diego except in July. But when I also look at this, Rochester has a high of like over 70 and a low below 20, whereas San Diego, alright, so I'm going to look at San Diego stuff. San Diego's low is around 45 and its high is like 60. So I can tell you that Rochester goes up and down. Rochester has a big difference in its temperature. Has a lot of variation. I think I'm ready to look at it now. So I'm looking for the conclusion. Number one, the average temperatures of the two cities are the same. No way. They would have to be side by side, the same amounts. The average temperature of Rochester varies more than San Diego. Oh my goodness. That one sounds right. 3, the average temperature of Rochester varies less than San Diego. Temperature varies less. No. Okay, so when it says this varies less, I had to think about that for a second. Because here, look at it says varies more, varies less. I got confused. So I'm marking up to make it disproof. This is definitely not correct because it definitely has more variation, more differences than San Diego. 4, the average temperature in both cities in August is different. We don't know that, right? There's no August here. Can you see that? I don't see any August. So it is 2. Number 13. Using the data in the table below, what kind of graphic best shows a trend? So if I were to take this, what kind of thing would show the trend? So month and high temperatures. Oh, look, we have the high temperature is increasing. I haven't been able to do that for a while, right? Because none of these have really shown that trend. All right. So, a line graph. Let's see. We go from February to August. Possibly circle graph. It's not a percentage. Data table. This is a data table. It's not bad. The Venn diagrams, like where you can compare and contrast stuff. So what would best show a trend? Well, here we can find a trend, right? But it's not as easy as looking at the line graph. So I would say 1 line graph. There we go. All right, ladies and gentlemen, that concludes this lesson.